Hello and welcome to another segment of Physics Concepts. Today we have the honor of having Dr. Matthew Gliboff, who works as a lecturer for the University of Washington, Bothell, joining us. Thank you, Dr. Gliboff, for taking the time to act as my expert. Let's get started.
All right.
First question. What are some preconceived ideas that people hold about the physics concepts that take place with cars?
So something I've seen in the news recently is the idea that we should not go for smaller, more fuel-efficient cars because it's safer to drive around in larger cars. I think this stems from the misconception that if a small car collides with a large car, there will be a larger amount of force on the smaller car. But Newton's third law tells us that the amount of force on each car is actually going to be the same. And in a collision, you actually have an additional disadvantage in a heavy car because you have more mass, you have more energy, and that energy needs to get dispersed. If you collide with a stationary object, then you have more energy in the collision that you have to get rid of. It's potentially less safe.
Mm-hmm. Then it's potentially less safe with a bigger car than a smaller car.
Yeah.
I understand. Wow, that makes a lot of sense. Next question. What forces need to be in action to ensure a car is standing still, moving, and spinning?
So when you drive a car, you put inputs into the steering wheel, gas pedal, and brake pedal.
Mm-hmm.
And so all of these require horizontal forces. Either you're speeding up, slowing down, or steering left or right. And the only horizontal force acting on your car is going to be due to friction. Mm-hmm. So actually always friction from the tires that accelerates, slows down, or steers the car.
Mm-hmm.
Which is surprising for a lot of students because typically we think about friction only in the context of slowing something down.
Mm-hmm. Yeah, that makes a lot of sense. You need that friction force that's really holding you to the ground, right? Okay. Most people don't understand the importance of physics when it comes to car crashes and car safety. Can you speak a little bit about the importance of good tires for scenarios with low friction, such as icy or rainy roads?
Sure. So a misconception I see a lot in 121 is if the car is moving, then most students say, oh, it must be kinetic friction because the object is moving. But kinetic friction actually refers to what the two surfaces are doing relative to one another. So if the surface of the tire is gripping the ground, then that would be static friction. The surface of the tire is sliding on the ground, that would be kinetic friction. Mm-hmm. And that's an important distinction because kinetic friction can only oppose the direction of the velocity. So if I spin out my tires or I lose my static friction, I go over to kinetic friction, then I don't really have any control over what the car is doing anymore.
Mm-hmm.
Because I lose my ability to use that friction force to speed up or steer or slow down the amount that I want. So it's important that the force between the tires and the road remains static friction, and that depends on the coefficient of friction between the tire and the road to determine my maximum static friction force of the tire on the road.
Okay, great. Do you have other comments to share with this community about car safety or the physics involved with cars?
Yeah, so one of the kind of main goals of accident safety is to reduce the amount of force on the occupants.
Mm-hmm.
So in a given collision, right, you sitting in the car have a certain amount of momentum. That momentum is equal to an amount of force times an amount of time that would be delivered to you if you lost all that momentum.
Mm-hmm.
So most collision technology is about increasing the amount of time that the collision takes, thereby reducing the amount of force on the occupant. Mm-hmm. So things like airbags mean that you slow down as the occupant more gradually, and other things like crumple zones, right, make the collision take longer and therefore reduce the amount of force on the occupant.
Okay, that makes sense. Thank you again for interviewing with me.